Hello everyone. In this video, we'll be going through project work number 3. This is the final project work alongside with your final examination, and it deals about linear regression and how to work with that. Okay. So this linear regression, I have tried to go for NBA players, what are their statistics and so on. All right. So yeah, please go through this. And first of all, you need to go for data collection. Okay, the huge time consuming part is the data collection. It will take some time. Okay, just have patience. Okay? So sign up for your favorite NBA team here in Canvas. Okay, so just write your team over here. Okay, and obtain 2 quantitative variables from each player on the NBA team. So what does that mean? Okay, those quantitative variable could be how many games they played, how many points they scored, how many 3-pointers they scored, how many 2-pointers or field goal, or how many free throws they scored, or how many tackles that they made, were they successful or not, or how many blocks did they made if the player is a defender, or there could be lots of variables, right? I will show you right away. So to do that, click the link, this one. Okay, just control click to follow, or just copy this one, www.nba.com/teams. go to nba.com and choose your favorite team. So here I will go to this website, which I have already opened. Okay, so this is the page. You can choose any team you like. Okay, so let me just choose, since I know this LA Lakers, so I'll just go over and click on profile. Okay, so here you get all the name of the current players, right? Okay, we need to write down the team. Okay, so you can write down, so I will write down LA Lakers. And what is the explanatory variable and response variable that you want to compare? Okay, does one has a relationship with another? Okay, so that's what we want to compare. Okay, so for that, what I will go for is, I'll just go for one player and try to see how does that look like. Okay, so let me click on this Russell Westbrook, then choose stats. Then you will land onto the page where Russell Westbrook's seasonal statistics is over here. Okay, according to the regular season and per game. Okay, just leave it default. Okay, and you can see that in the year 2021-22, okay, I think this year, this season, how many games did he play? 78 minutes. That's 34.3 per game, and points he scored is 18.7. Field goals made, field goals attempted. Okay, that could be 2 things that you may want to compare. Field goal percent. Okay, these 3 are the variables. Okay, 3-point made, 3-point attempted, 3-point percent, and blah blah blah. Okay, there are lots of variables that you can look onto. Okay, so yeah, you can see rebounds are there, and defensive rebounds, offensive rebounds, assists, turnovers, steals, blocks. What is this? PF, personal fouls, fantasy points, and I don't know what is this fantasy point, and what is this? Double doubles, triple doubles. Okay, so there are lots of variables that you can compare. Okay, so one of the things that you can compare is just like games played versus minutes played, or games played versus points, or field goals made versus field goals attempted, right? I think this could be field goals attempted could be X variable, and field goals made could be Y variable. You can compare that. If 3-point attempted, 3 points made, this also could be a nice comparison. Okay, so let me go for minutes that he played in each game, and total points he made each game. Okay, in each game, since we are in per game mode. So I will record that in an worksheet. Okay, in an Excel worksheet. You can see here that I have written down team LA Lakers, season 2021-2022, 2021-22. Okay, I have the player's name over here. Okay, and their corresponding minutes played and points scored. You can go for that. Russell Westbrook, he played 34.3 minutes per game. Okay, and points scored. I think I should write down per game. M. McClung, yeah, there's a particular interesting thing about M. McClung. Whenever you go to statistics, okay, you can go there, and yeah, if you click for stats, okay, that's what we do. Then yeah, traditional spirits, advanced blah blah blah. So here you can see that I think he changed the team, right? He changed the club. So he came from Chicago Bulls to LA. Since I'm just working on LA Lakers, so I just wanted to grab the statistics that he made while playing for LA Lakers. Okay, so just be careful with that. Other than that, it's fine. Okay. All right. So this is how you come up with a data points. Okay. As I was telling, the explanatory variable was minutes played per game. And I think you can throw this away, and points made per game. Okay. Is there any relation between them? Okay, so you can, so let me just throw this. Note that there are 16 to 17 players on each team, hence you'll obtain 32 to 34 data points to quantitative variables. Okay, so I told you earlier, this is my team. Okay, so let me just make it italic so that it will be a little bit distinct. Okay, so there are, you can see that there are 17 players over here. 17 times 2 is 34. Minutes played would be X variable, right? So that's what we compare. Minutes played is X, point scored is Y. I expect that points scored would be correlated to minutes played. Okay, so that's what I guess. Okay, I don't know whether I am correct or not. Okay, so then that's what happens over here. Okay, complete the table in MS Excel and paste it here. Okay, so for that you can just copy this thing. All right, copy it and paste it over there, just to make sure that nothing gets confused. I'll just write down every border. Okay, that's fine. I think Horton Tucker, his name is a bit longer. Everyone else, okay, so that's fine. And this also, okay, it looks good. Okay, analyze the data in MS Excel. Go to data analysis, select regression from the menu and click on OK. So you can do this question number 3, or work number 3 in GeoGebra as well. Okay, but here I want you to use the data analysis tool. Okay, so go to data analysis, select regression from the menu and click on OK, and select the data from Y range and X range. Be sure to select levels, confidence level, line fit, plots. Okay, all right, so let's go for that. So here go to data analysis. Now if you don't have that, if you don't see data analysis, then you should go for file, options, and then go to add-ins, right, and click on this and then click on this manage Excel add-ins and go, and then you make sure that there's a tick mark over here, okay, in analysis toolpack, and click on OK. So then you should be getting this. Okay, go over here and go for regression. Okay, just scroll down and go for regression, click on OK. Input Y range. First of all, we need to go for Y range. Y range is this one, and X range is this one, minutes played. And there levels, yes, we have levels. Confidence level 95%. Okay, so that's fine. And what else we want line fit plots. Yeah, this one. Okay, we want this one. We don't want residual plots and so on. So click on OK. So in another page you get this thing. Okay, so you can see what is happening over here. I hope you can understand this one, right? Calculate these following. Okay, so for this one you can either go for GeoGebra, or you can stick to Microsoft Excel. Okay, and so let us go for these things. Okay, so we basically need to find the regression line, okay, in here. So let's try to work on that. So just go for this one and just write down this one. So that looks good. Yeah, click on insert, and this one is scatter plot. Point scored is Y. So you can write down minutes played versus points scored. Axis titles also, we want that. Data levels, we don't want that. We don't want grid lines. Okay, legends. Trend line, we want trend line, and this trend line Go for more options. Yeah, linear. Display equation on chart. Display R values. Here. Here. Good. Okay, and I want this line to be, okay, hold on. I want this line to be a bit nice. Okay, so dash type would hold one. That's good. This is what I want. This is minutes played. This is points scored. Okay, equation is written in this way: a plus bx. All right, or you can write down bx plus a, however you might want. Okay, so this would be then 0.8607 9.3036. 0.8607x minus 9. N is what? N is 17, right? We all know that. N is 17. R square is what? R square, we need to find that again from this one. 0.808. Correlation coefficient is what? Correlation coefficient is, you can just square root this thing. Yeah, or yeah, let's find the square root. So the 8993. Okay. B is 0.8607 and A is negative 9.3036. So that's it. All right, so we have written down everything. Obtain the scatter plot in MS Excel and sketch the regression line. You can just click on this, copy it and paste it over there. Paste it over there. Looks good. Okay, nothing wrong with that. By doing this one, it will just make sure that you can throw it anywhere you like. Okay, just click on this. After clicking on this picture, you click on this formatting layout options and go for behind the text. All right, so that's fine. It looks fine, right? So minutes played, points scored, and the equation is there, regression line is there, R square is there. Okay, so that looks good. Now discussion question: does the line seem to fit data? Why? Yes, it seems to fit the line. Most of the points are very close to each other. Yeah, you should write that down over here. Yes, most of the data points are very close to the line. Okay, so interpret the correlation coefficient in context of relationship between the chosen NBA players explanatory and response variable. So correlation coefficient is what? R equals to 0.8993 suggests that significant relation between the minutes played per game and points scored by a player of this team. Okay, so minutes played was X, right? And points scored was Y, right? Interpret the slope and y-intercept in the context of chosen NBA players explanatory and response variable. Okay, so what does y-intercept mean at first? Okay, I can write that down. Intercept means y equals to negative 9.3036. Okay, means that if a player plays for 0 minutes, he will score negative 9.3036 points, which has no meaning, which has no logical meaning in this context. Okay, what does y-intercept means? Okay, y-intercept simply means that you will be getting negative 9.3036. So that's the point score per game if you play for 0 minutes. Okay, so which is not so logical, right? Since since you know that you can't score negative points, right? Or does that mean that you score onto your own net, one side? Okay, so this is y-intercept. Slope is equal to 0.8607. 0.8607 means that if a player plays 1 additional minute, then he will score 0.86 points more. Okay, so this is how we need to interpret the slope. Are there any outliers? So if so, which points are an outlier? So basically, in this context, you can simply say that this point may be an outlier, right? I think that should be of LeBron James, right? Okay, so that's fine. But these points are very close, right? These points are very close, and yeah, and they are within the range of what we experience. But if we discuss about what really outliers are, then it should be farther than 5 or 6 standard deviations. So I don't think that this should be that far, right? Farther away from 5 or 6 standard deviation farther away. So I would say no in this case, right? But if you talk about LeBron James' score, right? Yeah, you can see that over there. Yes, LeBron James, where is he? Yeah, 37.2, 30.3, right? It's very high than everyone else, right? The closest one is Anthony Davis. Okay, yeah, you can think about that. So in this situation, I won't say no outliers. Or if you want to say that, okay, there's an outlier, okay, and no outliers, if you can say yes, then you should say that this point 37.3 comma 30.3 is an outlier. You can say that, but you should give a logical reasoning about that. Okay, but I feel like that there is no outliers. Okay, you may have that kind of situation. Okay, should the outlier, if exists, be removed? Why or why not? Okay? No outliers in this case, so that's fine. So this is we don't need to answer this question. And if it is an outlier, if you consider this is an outlier, should you remove this one? Okay. What happens if you remove that? Would that change the whole dynamics of the entire regression line? I don't think so. It won't. Okay, I don't think so. Construct a hypothesis test claiming there is a significant relationship between the explanatory and response variables. That is, the population correlation coefficient is significantly different from 0. Okay, so this one was 0.8993, right? So that was R coefficient at alpha equals to, let's suppose, 0.05. Yeah, or you can simply write down 95% significance level, or that is 0.05. Okay, there is a significant relation between the minutes played versus and points scored per game by a player. So now, since this one is, there's a significant relationship between this one. Okay, so that means this would be exactly opposite, right? There is not a significant relationship. I should say that there is no significance relation. There's no significant relationship between the minutes played and the points scored per game. So that's the null and alternative hypothesis. To find out the test statistics T and the p-value, okay, we need to go for, you go to geogebra.org, classic has probability, and go for t-test difference of means, and you will be getting this one. So null hypothesis is equal to 0 and alternative hypothesis is not equal to 0. That's what we have assumed whenever we were trying to work on this one. You can see that there's a significance relationship between them, means difference between the two means is 0. Okay, and that's not 0 for alternative hypothesis. So okay, null hypothesis is this one, and this one is the alternative hypothesis, right? So mean is, yeah, so let's go for this first one. For the first one, mean is 23.37, 23.38, and is 17. It's also 17. And mean of the second one is what? Mean of the second one is 10.82. Okay, so that's fine. Now let us find the standard deviation for both. STDEV standard deviation is this one. Okay, 7.67. And standard deviation of the next one goes to STDEV. Okay, 7.345. Okay, so that's fine. So standard error is this one. So the degree of freedom is 32. The test statistics is 4.8764 and P is 0. So test statistic is 4.87 and P. Okay, so that's it, and P value is 0. So since P value is less than test statistics 4.87 and P value is 0. So 0 means actually it is a very small number, so that's why they wrote down 0. Okay, here P equals to 0 is less than 0.05, which is the alpha value. Okay, so yeah, then we do not reject the null hypothesis. Okay, that's it. And also we go for yes. Okay, so in both ways we can win that way. Okay, so that's fine. So I hope you understood this thing. Okay, and this is all. So right, so I will just write down this is true. Okay, this is all for the for our project work. Thank you so much, and complete it as soon as possible. Thank you.